Session is called Packet Collection, Performance and Techniques by Mike Patrick from Red Hat. So take it away.
Hello, I'm Mike Patrick representing Red Hat. Today I'll be talking about packet collection in Open vSwitch. The reason for this talk today is we have a tool called OVS TCP dump that is very convenient to use. This is especially true when it's used in conjunction with DPDK ports. It is simply the easiest way to collect packets off of a DPDK connected network card or a vhost user port. It is also the simplest way to collect packets as they transit any port on a bridge at all, or even all ports simultaneously when the mirror is configured in span mode. However, in the past, this tool has significantly impacted throughput, preventing its usage in production environments. Over the past year, I've been looking at solutions to this problem so OVS TCP dump can see wider adoption. Before we continue, I should explain a bit about how the OVS TCP dump tool works. This tool is a very simple Python script. First, it creates a virtual port and configures a mirror in Open vSwitch to forward traffic from the specified port to the mirror port. Then, it launches TCP dump to filter, display, or perhaps even save the collected traffic in a PCAP file. And finally, it contains some cleanup code to remove the mirrored port, virtual interface, and shut down TCP dump on close. Despite this simple design, this tool can be very useful in debugging issues with traffic delivery by confirming or refuting OVS's delivery of packets on a specific interface and capturing the packet's content to verify that the packet's content is correct and hasn't been corrupted and has been transformed appropriately as is expected by the OpenFlow rules. Some users may not realize that Open vSwitch 2.17 contained a significant performance improvement to the OVS TCP dump tool. This performance improvement is especially visible with the kernel data path, as we will see on the next slide. This improvement does not require any change to the compiled code, such as vSwitchD and OVSDB, so users do not have to upgrade their Open vSwitch installation or experience any downtime to take advantage of this performance improvement. They simply need an updated copy of OVS TCP dump, which, as mentioned, is just a Python script. The change was the simple adoption of the dummy driver for the virtual interface instead of setting up TUNTAP ports for packet reception. This provided a significant reduction in the amount of processing that packets needed to undergo before they could be received by TCP dump. This table lists the relative performance impact across several different configurations. In this test, I saturated network traffic between two interfaces and measured the reduction in throughput caused by sampling all the packets with OVS TCP dump. As you can see, the impact of OVS TCP dump with the kernel network data path was significant prior to this patch, but now it is relatively minor and could be considered for use in a production environment when the user wanted to debug whether or not packets were being delivered appropriately. However, the impact with the user space data path is still quite significant, and users of Open vSwitch user space data paths in production environments may be hesitant to deploy this tool to debug traffic issues if this tool causes a 10 to 30% reduction in throughput. So clearly, other solutions are required. Looking forward to the future, I am currently working on a change that could significantly improve the performance in some situations and may make the use of OVS TCP dump more palatable in some user space data path configurations. The idea is to filter packets at the OVS level instead of mirroring all packets to an interface and then filtering later with TCP dump. If the user only wants to collect a subset of packets on an interface, for example, a specific protocol or specific communicants, this can be done inside of Open vSwitch and will not noticeably impact the transmission of any flows that do not match that filter. To measure the benefit of pre-selection, I set up multiple different connections, including one that transmitted a few packets per second. This would be a simulation of trying to collect low bandwidth traffic like RCMP, ARP, etc. from a live workload. The results here would be very different and would show no improvement beyond the previous table if a high bandwidth connection were selected instead of a low bandwidth connection. But these results show a lot of promise for use in specific cases where the user of a user space data path wish to collect a low bandwidth protocol for debugging purposes. With this feature, they would see a very low 1% impact on their on the performance of their network traffic. This is just a preview of a change that I'm proposing on the mailing list, and I'm currently working with maintainers to see its inclusion and availability for everyone. I'm hoping to see its availability in OVS sometime in early 2024. One final problem that exists with OVS TCP dump is the exclusive use of netdev Linux when mirroring packets from a user space data path. The problem is that netdev Linux runs out of the OVS main thread and so can slow down or be slowed down by other activities in OVS. Ideally, we would move this to a PMD thread, and a simple way to do that is simply by mirroring to a DPDK interface. DPDK does provide several methods of sending packets to and receiving them on virtual interfaces. However, Open vSwitch does not currently know what DPDK drives are available during runtime, and thus OVS TCP dump cannot currently detect if it is even able to take advantage of these DPDK virtual port drivers. Furthermore, the impact on performance is difficult to quantify, as it is highly dependent on what interface types traffic is flowing from and to. This is especially true if the intended traffic does not flow through DPDK ports anyways. More research is needed to determine what benefits this will have and in what situations. Furthermore, the operation of netdev Linux interfaces in the OVS main thread is a bigger issue than just for packet capture. This restricts throughput on all user space interfaces other than DPDK and AFXTP. An example of how this could really affect performance is a configuration with a lot of containers, with many of these containers communicating locally. However, as mentioned, this is a larger problem currently in OVS. For example, currently OVS does not support checksum offloading of netdev Linux ports unless user space TSO is enabled, which is not the default configuration. So local packet transmission will need unnecessary checksumming, and all connections will have to route through this one primary thread. This is clearly a more serious problem that should be addressed in the future and affects use cases beyond that of packet capture. This concludes my presentation. Thank you very much for attending, and I await any questions that you may have.
All right, so let's see if there's already some questions out there. I don't see anything yet. I think Mike is online, right, Mike? Are you there?
I sure am.
Cool. Yeah, in lack of other people asking questions or waiting for some questions to come in, did you, when you were doing the DPDK part, or you're suggesting to work on the DPDK side, do you mean that you are trying to do dynamically, for example, add a vhost driver into the equation and then use that to TCP dump on?
Yes, exactly. The ideal situation is if OVS TCP dump could detect if the ports that it was monitoring were DPDK, and in that case automatically set up a DPDK-based port, either vhost or any other type of virtual interface that's available to monitor on.
Okay, Nice. Yeah, I think that's a very nice solution. But yeah, like you said, it's probably hard to make sure that that device is available and get assigned maybe to the correct PMDs if people are taking care of that or are, how would you say it, are in need of specific PMDs to be used rather than some general ones.
Exactly. And one thing I don't believe I mentioned on the presentation was this will also have some impact with RxQ allocation, especially if you have dynamic RxQ rebalancing. Creating a new DPDK port could potentially change, affect the topology of how traffic is being flown through OVS, and that will have an impact on throughput. I do see that there is a question in chat. What does percent mean? Very good question. That is the percentage of decrease in network throughput. So I saturated a connection with, in some cases, IPERF3 and measured the throughput that OVS was sending through that link, and then did a second measurement when OVS TCP dump was enabled. So that's not a change in CPU usage, just a change in network throughput.
All right, thanks for answering that, Mike. I see another question in the Q&A section. So one from Flavio. He's asking if we can run multiple instances of OVS TCP dump in parallel.
Yes, that is absolutely possible. However, there is no protection to make sure that you don't do something with one OVS TCP dump that might conflict with another OVS TCP dump. This could be a problem because OVS TCP dump will attempt to create a mirror interface automatically, and it uses a very simple algorithm for this of just adding the characters MI to the start of the interface that you're monitoring. So if two separate users independently attempted to use the same OVS TCP dump to monitor the same interface, one of those attempts would fail.
Okay. All right. So there are some limitations, but in theory, if we're not causing any collision, it should be fine.
As Aaron mentions in chat, that can be disabled though as a separate option. If the same person is running all copies of OVS TCP dump, then that will also not be a problem because they will be aware that they're monitoring certain interfaces, and in that case, it will work perfectly fine.
Okay. All right. Thank you. There's one other question I see here from Ilya, and he's more wondering from a DPDK side if a API to query the available drivers would help, if there is one. Maybe already, but I guess you don't know.
I spoke a bit about this with I believe David Marchand at the face-to-face meeting, and one possible option is the fact that when we compile, we can easily tell what drivers are available, and because OVS TCP dump does get sort of compiled with the rest of OVS, it gets transformed during the build process. We could insert information about what drivers are available. However, it is if the DPDK drivers are dynamically linked, then they could change over time as DPDK gets upgraded or modified, and that would not be taken into account. And I'm not familiar with any sort of DPDK API to detect what dynamic drivers are available without trying to use them.
Okay. Thanks. So that's maybe some more research, some more work for the DPDK community to figure that one out. I'm going over the chat. I see no more questions. Let me one more check on the Q&A. Yep, no more questions there. Anyone else? A final question for Mike? Looks like it's all silent. So thank you very much, Mike, for your presentation.